What is RFID module? How does it function and its application? What is an RFID module? An RFID, radio frequency identification, module is a device used to read or write data to RFID tags using radio frequency waves. These modules are integral in systems designed to identify, track, and manage assets, products, or individuals using RFID technology. How does an RFID module work? Components of an RFID system. RFID Reader, or module, sends and receives radio signals to EFROM tags. RFID Antenna emits and receives electromagnetic waves. RFID Tag contains a microchip and antenna, stores unique data. Basic working principle. The RFID reader emits a radio signal via its antenna. This signal powers the RFID tag if it's within range, for passive tags. The tag's microchip processes the signal and sends back data stored in its memory. The RFID reader receives the signal, decodes it, and processes the information. Communication protocols. RFID modules communicate using specific frequencies, e.g., LF, 125 kHz, HF, 13.56 MHz, or UHF, 860 to 960 MHz. Data can be transmitted wirelessly between the reader and tag. An RFID module facilitates the communication between an RFID reader and an RFID tag, enabling data transfer through radio frequency, RF, signals. Here's a step-by-step breakdown of how it works. 1. Initialization. The RFID module, or reader, generates an electromagnetic field using its antenna. This field operates at a specific frequency, depending on the system, e.g., LF, 125 kHz, HF, 13.56 MHz, or UHF, 860 to 960 MHz. 2. Powering the tag. If the RFID tag is passive, does not have a battery, it gets activated when it enters the electromagnetic field. The tag's embedded antenna captures energy from the reader's signal to power its microchip. For active RFID tags, with a battery, the tag can transmit signals over a greater distance without relying on the reader's energy. 3. Communication and data exchange. Once powered, the RFID tag transmits the data stored in its microchip back to the reader. Data transfer occurs through one of two methods. Inductive coupling, used in LF and HF systems, utilizes a magnetic field for short-range communication. Electromagnetic wave propagation, used in UHF systems, allows for long-range communication via RF waves. The reader captures this data and decodes it into a usable format. 4. Data processing. The decoded data is sent to a connected system, e.g., a computer, microcontroller, or server, via serial communication, e.g., UART, SPI, I2C, USB. The host system processes the data for further actions, such as logging, tracking, or triggering automated responses. 5. Feedback or action. Based on the data, the system can perform actions like granting access, updating inventory, or recording a transaction. Key functions in RFID communication. Read/write capability. Some RFID tags are read-only, data is pre-written and cannot be modified. Others are read/write, data can be updated dynamically by the RFID module. Anti-collision protocol. Allows multiple tags in the reader's range to communicate without interference. Ensures accurate data retrieval from one tag at a time. Summary. The RFID module works by creating a field to power and communicate with RFID tags using RF signals. It receives data from the tags, decodes it, and sends it to a processing system. It facilitates contactless identification and tracking, making it valuable across industries. If you'd like, I can explain specific components of the RFID module in more detail. Applications of RFID modules. RFID modules are versatile and used across various industries to enable automation, identification, and tracking. Here are some of their primary applications. 1. Inventory and asset management. Warehouses and retail track products, monitor stock levels, and reduce manual inventory efforts. Tools and equipment. Ensure tools and assets are tracked in industrial and construction settings. 2. Access control systems. Workplace security. Use RFID-enabled ID cards to grant or deny access to employees for secure areas. Residential and commercial buildings. Manage entry points using RFID-based keycards or fobs. 3. Transportation and logistics. Toll collection. Automatic toll payments using RFID tags on vehicles, e.g., FAS tag in India, Easy Pass in the US. Fleet management. Track the location and status of vehicles in real time. Cargo tracking. Monitor goods during transit for supply chain optimization. 4. Healthcare. Patient identification. Track patient information and link it to their medical records. Medical equipment. Monitor the location and usage of high-value medical devices. Pharmaceuticals. Authenticate and track drug shipments to prevent counterfeit drugs. 5. Retail and e-commerce. Checkout automation. Speed up transactions by scanning RFID tag products at checkout. Anti-theft systems. Detect unauthorized removal of products from stores. 6. Agriculture and livestock management. Animal tracking. Use RFID tags to monitor livestock health, breeding, and location. Smart farming. Manage irrigation systems, equipment, and harvest logistics. 7. Transportation systems. Public transport. RFID cards or tokens are used for contactless ticketing, e.g., metro systems. Parking systems. Automate entry and payment for parking lots. 8. Libraries. Automate book check-ins and checkouts to improve efficiency. Prevent theft and misplacement by tracking book locations in real time. 9. Manufacturing. Production line tracking. Monitor items as they move through different stages of manufacturing. Quality control. Trace defective products back to specific production batches. 10. Military and defense. Weapon tracking. Monitor and control access to firearms and other sensitive equipment. Personnel identification. Ensure secure identification of soldiers in sensitive areas. 11. Events and entertainment. Ticketing systems. Use RFID wristbands or cards for seamless entry to concerts, festivals, and sporting events. Cashless payments. Enable quick transactions at event stalls or concession stands. 12. Smart cities and IoT. Waste management. Track bins and optimize collection routes. Energy management. Monitor utility meters and energy distribution systems. Benefits of RFID in applications. Contactless operation. No direct line of sight is required. Efficiency. Speeds up data collection and reduces human error. Scalability. Handles large volumes of assets or users simultaneously. Real-time tracking. Enables precise, up-to-date information. RFID modules play a crucial role in automating processes and enhancing efficiency across industries. Would you like to discuss any specific application in more detail? Types of RFID modules. RFID modules are categorized based on factors like frequency, functionality, and tag type. Each type is suited to specific applications depending on the range, speed, and environment. 1. Based on frequency. A low frequency, LF, RFID modules. Frequency range, 30 kHz to 300 kHz, commonly 125 kHz or 134.2 kHz. Features. Short reading range, up to 10 centimeters. Less affected by metal and water interference. Lower data transmission rates. Applications. Animal tracking, e.g., livestock and pets. Access control, e.g., RFID key fobs. Industrial automation. BL high frequency, HF, RFID modules. Frequency range, 3 MHz to 30 MHz, commonly 13.56 MHz. Features. Reading range up to 1 meter. Moderate data transmission speed. Widely adopted standard, e.g., NFC, near-field communication is part of HF RFID. Applications. Smart cards and payment systems. Ticketing for public transport and events. Library systems. C ultra-high frequency, UHF, RFID modules. Frequency range, 300 MHz to 3 GHz, commonly 860 to 960 MHz. Features. Long reading range, up to 15 meters or more. Fast data transmission rates. More sensitive to interference from metal and liquids. Applications: supply chain and inventory management, vehicle identification and toll collection, logistics and asset tracking, microwave RFID modules, frequency range 2.45 GHz or higher. Features: long reading range, similar to UHF, higher data transmission speeds. Applications: high-speed toll systems, advanced IoT applications. 2. Based on tag type. A. Passive RFID modules. Function: read and write data to passive RFID tags, tags powered by the reader's signal. Features: no internal power source required for tags. Short to moderate range. Economical. Applications: inventory management, access control. B. Active RFID modules. Function: communicate with active RFID tags. Tags have an internal power source. Features: longer range, up to 100 meters or more. Higher cost due to battery in tags. Suitable for tracking moving assets. Applications: fleet tracking, real-time location tracking in large facilities. C. Semi-passive RFID modules. Function: works with tags that have a battery but rely on the reader's signal for communication. Features: longer range and faster communication than passive tags. Battery assists in powering onboard sensors or memory. Applications: cold chain monitoring, temperature-sensitive shipments, environmental sensing. 3. Based on functionality. A. Read-only RFID modules. Function: reads pre-programmed data from the tag. Applications: asset tracking, simple identification systems. B. Read-write RFID modules. Function: read and write data to the tag, allowing dynamic updates. Applications: reconfigurable systems, e.g., reusing RFID tags for inventory. 4. Specialized RFID modules. A. NFC, near-field communication, modules. Frequency: 13.56 MHz, subset of HF RFID. Features: short range, a few centimeters. Allows two-way communication. Applications: mobile payments, e.g., Google Pay, Apple Pay, digital wallets, and contactless cards. B. RFID plus IoT integrated modules. Combines RFID with sensors or GPS for advanced tracking. Applications: real-time shipment tracking, environmental monitoring and logistics. Choosing the right RFID module. Short range, LF or HF for access control or small-scale asset management. Long range, UHF or active RFID for logistics and vehicle tracking. Data speed, UHF or microwave for faster data transfer. Special use cases, NFC for contactless payments, IoT integrated modules for smart systems. Would you like to explore any of these types further? Advantages of RFID technology. RFID modules offer numerous benefits compared to traditional tracking and identification technologies like barcodes or manual systems. Here's a comprehensive overview. 1. Contactless data transmission. No direct line of sight needed. Unlike barcodes, RFID tags can be read through materials like cardboard, plastic, or even clothing. Convenience. Allows for faster and easier scanning in busy environments like warehouses or retail stores. 2. High-speed operation. RFID systems can read multiple tags simultaneously, reducing scanning time compared to one-by-one barcode scanning. Supports rapid data processing for high-volume operations, such as inventory management or toll collection. 3. Enhanced range. Tags can be read at various distances. LF and HF RFID. Short ranges up to 1 meter. UHF and active RFID. Long ranges up to 100 meters or more. 4. Large data capacity. RFID tags can store more data than traditional barcodes, including serial numbers, batch information, and even sensor data, e.g., temperature or humidity. 5. Reusability. RFID tags, especially read/write tags, can be updated and reused, reducing long-term costs in certain applications. 6. Durability and longevity. RFID tags are robust and can withstand harsh environments, including high temperatures, moisture or water exposure, physical wear and tear. 7. Automation and efficiency. Automates processes like inventory counts, access control, and asset tracking, significantly reducing manual labor and human error. Integrates easily with IoT systems for real-time data collection and monitoring. 8. Anti-theft and security. RFID tags can help prevent theft or unauthorized access by triggering alarms when items leave a designated area without proper authorization. Encrypted data and secure communication protocols enhance security against unauthorized access or duplication. 9. Scalability. RFID systems can handle a large number of tags simultaneously, making them suitable for scaling up in businesses like logistics, retail, or manufacturing. 10. Versatility. RFID is used across multiple industries and applications, such as healthcare, retail, transportation, and smart cities, adapting to diverse needs and environments. 11. Real-time tracking. Provides real-time location and status updates for assets, vehicles, or shipments, enabling better decision-making and operational efficiency. 12. Reduced costs over time. Though initial setup can be costly, RFID systems save money in the long run by reducing labor costs, minimizing errors, optimizing operations. 13. Environmentally friendly. By reusing RFID tags and eliminating paper-based tracking systems, RFID technology can contribute to sustainability efforts. Comparison with other technologies. Feature RFID barcode. Line of sight needed, no yes. Range up to 100 meters, a few centimeters. Durability high-low. Read speed high, multiple tags, low, one at a time. Data storage high-low. Would you like more details on RFID's advantages in a specific industry or use case? Challenges of RFID technology. Despite its numerous advantages, RFID technology faces several challenges that can limit its adoption or effectiveness in specific scenarios. Below are the main challenges. 1. High initial costs. Setup costs. RFID systems, including tags, readers, antennas, and integration software, can be expensive to implement, especially for large-scale operations. Tag costs. While prices are decreasing, active RFID tags and specialty tags, e.g., rugged or sensor-enabled, remain costly. 2. Interference issues. Environmental factors. RFID performance can be affected by metals, which reflect or absorb RF signals, liquids, which can weaken or block signal transmission, signal overlap. Multiple RFID readers in close proximity can cause interference, reducing reliability. 3. Range limitations. Short range for passive tags. Passive RFID systems have limited ranges, a few centimeters to a few meters, which may not be suitable for certain applications requiring long-distance tracking. Dependence on frequency. Higher frequency systems, e.g., UHF, offer longer ranges but are more susceptible to environmental interference. 4. Privacy and security concerns. Unauthorized tracking. RFID tags can potentially be read by unauthorized readers, leading to privacy violations. Data cloning. Without encryption, RFID data can be intercepted and cloned. Cybersecurity risks. RFID systems integrated with IoT or cloud platforms may be vulnerable to hacking or data breaches. 5. Lack of standardization. Different RFID frequencies and protocols are used globally, e.g., UHF standards differ between regions, complicating interoperability and cross-border applications. Proprietary systems may lock users into specific vendors, limiting flexibility. 6. Complexity of integration. Integrating RFID into existing IT systems or workflows can be challenging and requires technical expertise. Compatibility issues with legacy systems can delay implementation. 7. Read accuracy challenges. Tag collision. When multiple tags respond simultaneously, data collisions can occur, reducing read accuracy. Reader sensitivity. Poor quality readers may fail to detect tags consistently, especially in dynamic or cluttered environments. 8. Maintenance and reliability. Active RFID tags require battery replacements, increasing maintenance efforts and costs. Readers and antennas may need regular calibration or upgrades to maintain performance. 9. Ethical and legal issues. Regulatory compliance. Different regions have varying regulations for RFID use, especially for personal data protection. Ethical concerns. RFID usage in personal identification, e.g., implantable tags, has raised ethical debates about human tracking. 10. Environmental concerns. RFID tags, particularly disposable ones, contribute to electronic waste. Recycling and disposal of RFID components are not always environmentally friendly. 11. Scalability challenges. While RFID is scalable, the complexity and cost of implementing systems in very large-scale applications can be prohibitive. Managing and troubleshooting large networks of readers and tags can be resource-intensive. 12. User resistance. Employees or customers may resist adopting RFID technology due to concerns about privacy, surveillance, or job automation. Mitigating these challenges. Cost reduction. Use passive tags where possible to lower costs. Leverage economies of scale for large deployments. Improve security. Implement encryption and authentication protocols. Use anti-collision algorithms and secure readers. Interference management. Use shielding techniques to minimize metal and liquid interference. Deploy frequency-appropriate solutions for the environment. Regulatory compliance. Follow global and regional RFID standards, e.g., EP Global, ISO. Work with legal experts to address privacy concerns. While these challenges exist, advancements in RFID technology and best practices continue to mitigate many of these issues, making RFID increasingly reliable and accessible. Let me know if you'd like details on overcoming specific challenges.